Hello and welcome to this lecture series on curl, divergence and gradient. So far we've looked at curl, we've looked at divergence and we've looked at gradient. So if you missed those part of those videos, kindly check the playlist on engineering analysis and then you'll find them there. But right now we want to look at the difference between all these three operations. So what's basically the difference between gradient, divergence and curl in terms of calculation exactly? Because sometimes you might know the three and then you might just get confused with which one to apply and what I'll do. So I'll be talking about that in this video. So now let's look at number one. So if you are dealing with grad, first thing you need to know about every of these things is their notation. Exactly. So for grad, the notation is always like this. And then, so throughout this video, we are going to be using, let's take our function. Exactly, let's represent our function for the particular vector that we are dealing with. Or whatever function it is, let's just take it as phi. Exactly. So if you are asked to look for the grad of phi, so you need to know the notation. So it is always represented with this. Exactly. So this is for grad of phi. Now if you are also dealing, so if you are now dealing with the div, so if you are asked to maybe look for div of phi, so the notation will be like this. Are we good? And then for the last one, if it is curl that you are dealing with, so for curl of phi, the notation will be like this. Then the cross product of phi. Are we good? So that's the first thing you actually need to understand when you are doing the difference between grad, div, and curl. So another thing is in the answer that you are going to get. Exactly. So in your final answer, when you are dealing with curl operations, in your final answer, they are always in having coordinates. I mean direction, or should I say coordinates, such that if you have your answer, you are going to be having it in ijk. So this is what I'm saying. So if you have this particular function now, and then you've gotten your answer to be whatever it is. So let's just say axi plus ayj plus azk. So plus azk. So your answers will always have this ijk when you are dealing with curl. Exactly. All things being equal, your answer will have ijk. The only time you might not have a particular coordinate is maybe when that coordinate is 0. So, but maybe if our j is 0, we might just have just this and this. Exactly. So just like we have for curl, if you're also dealing with grad operation, your answer that you're going to be getting will also have the ijk coordinate. So it will also have whatever value you get, is just be something like this. So you're also going to be having the I, J, and then the K. So it's only when you are dealing with div, you won't have how should I write it now? You won't have those I, J, and K in your final answer. So that's another thing that you can also use to differentiate it. Are we good? So we've looked at 1, 2, and then so let's look at another thing that you can also use to differentiate the difference between curl, divergence, and curl, divergence, and gradient. So another thing is the formula. So if you're asked to look for grad of phi, so then just note that the formula will just be the partial differential of phi over partial differential of x. Then don't forget your I plus partial differential of the function over partial differential of y. Then j plus partial differential of the function, which is phi over partial differential of z. Then k. So just take notes. You can see this I, j, and k will be there. Then x, y, z. So just note the order in which it is being written. Now, when you move over to div, just like we have it, is the dot product of this nebula, the del sign. So which will be given as. So you first of all write this out, which is partial differential over that of x and I plus partial differential over that of x, y, j, plus the partial differential over that of z and then k. So we use that to dot the function itself. So let's just say the function file is axi plus ayj plus azk. So you use it to cross axi plus ayj plus azk. So I've done example on this so you don't have problem with this, so I'm just saying it for proper understanding. Then when you are now dealing with call, exactly, so when you are dealing with call, first thing that should come to your mind is that diagram that looks like a matrix, a 3x3 matrix, that drawing that you do when you are calculating for the determinant of a 3x3 matrix. So once you remember that, just know that you are dealing with call, or when you want to deal with call, just remember that, oh, that 3x3 matrix diagram that you usually use to find the determinants of that matrix. So with that, you're going to be having something like this. You have I, j, and k, and then you're going to be having d over dx, then partial differential of d over dy, partial differential d over dz, and then the function itself will come here, so that will be ax, ay, az. So you don't need to add the I, j, and k in the third rule. So you don't need to add that. So this is for call. So basically, if you can remember all these three differences, you won't have problem with knowing which one is grad, which one is dive, and which one is call. So then the last one I want to just add is just like a reminder, exactly, because I've mentioned it in the course of the lecture series on this particular topic, is the solenoid vector. So when you are dealing with dive, and once the divergence of a particular function is equals to 0, just know that so that is when, so taking a file when it is equals to 0, so just know that it is a solenoid. It is a solenoid vector. And then if it is call, so if we have the call of file, which is represented as this, so if your answer is giving you 0, so just know that it is irrational. Exactly. So these are some of the differences between the call, the divergence, and the gradient. So if you find value in this, please give it a thumbs up, and if you have any question or doubt, do not hesitate to leave it in the comment section. So with this now, we are done with call, divergence, and gradient. So if you miss any part of this video, just check the playlist on engineering analysis. You'll find them there. Please don't forget to like, share, subscribe to the channel, and I'll see you all in the next topic.